So today we'll go over the two sections of homework, which is 8.3 and 8.4, which is all about vectors. And then I will remind students about your finals. So I'll show you what's going on with the finals here. So your final is going to be on Monday, December 14. It's a take-home final. I will post it in D2L and also will send it to you to school college email. So make sure you check your email address, check your college email, or check D2L if you're on D2L on Monday, December 14 at noon. Then the take-home test will be due on Tuesday, December 15 at noon. It will cover chapter 6, 7, 8, and 11. And as usual, once you finish your test, make sure you scan the paper for me, your test with your scanner or your apps, scanning apps in your phone, and then send it to me through the college email. So same thing like midterm that you guys did. So make sure you guys do that. And the only thing is your midterm is only 30%. Your final is 35%. So this final is actually a bit more than your midterm. So it's a 35% of your total grade. Where do you guys review for your midterms? I will suggest you to go to the textbook. Okay, and then when you go to the textbook, go to chapter 8. Go to chapter 8. Or if you have an ebook, you go to chapter 8. If you have a textbook, go to the very end of chapter 8. Okay, so for you have ebook, very end, which is called the cumulative test for chapter 6 to 8. So this is the one that you click on it, cumulative test for chapter 6 to 8. This is where your review is. So this review actually start for chapter 6, 7, 8. And as you know that your test is 6, 7, 8, and 11. So what you need to do here is 11, I think you guys are fine because it's not too difficult, but geometric and sequences and series arithmetic, this is a bit easier. But for 6 and 8, if you want to review, this is the one. So there are around how many questions? Quite a lot of questions here, 48 questions here. So this is for chapter 6, 7, 8, and then 11, you just go to the end of chapter 11. That will be a test for chapter 11. So I would recommend you to use that for chapter 11. So I think you'll be fine with chapter 11. Okay, so this is where you review for your finals. 6, 7, 8, and then 11 is just this. So you can go to the chapter 11 test. And then you can look at this. Usually it's the first few. So for chapter 11, I think you do until number 9 or something like that. Number 9, yeah, number 9. Because the rest is all going to be non-Pascal. Yep, number 9, 1 to 9. So this is for chapter 11. So so I would recommend you guys to practice this for your finals, for your test. All right, so we're going to talk about 8.3 today about your vectors. So do you guys have any questions on the vectors 8.3? One thing I want to point out to you guys, some of you already sent me an email that the I and J or the U and W that you use here are vector form. So do not use IJ in your keyboard or UW in your keyboard, because if you put that, they will mark you wrong. So you have to actually use the site on the right side. You have to click vectors and IJ here, or you have to make it bold. So make sure that this is what they want you to do. So make sure in your in this section 8.3 and 8.4, both sections, I think 8.5 also is bit vectors. So if they're asking for vectors, make sure you put it in the bold form, or if that is in IJ, just use I and J here. Okay, so this is one thing that a lot of students make mistakes in the test. Did you get it right? It's just you put IJ in the normal IJ form. So that's the reason why they're in the keyboard without bolding them. So, or without putting an arrow signs on it, because that is not a vector. This IJ is a variable. And if you bold it like that, that's the vector. So make sure you guys know the difference between a vector and a variable. Okay, Ryan, Parker, you okay?
Yep.
Yep. So I think you guys So I have one questions. I got a few questions here that I want to go over because it's going to be in your test. And I see a lot of students have getting it wrong here. So 32 and 34 is what I am talking about in this case. So let's take a look at 32 here. Okay, there are a lot of ways for us to do vectors. One way is actually you can use law of sine or law of cosine to do it. So question 32 is one of them. So we got two force. One force is 40 pounds and the other force is 75 pounds. And you got a resulting force of 95 pounds. And you have to find the angle between the two forces, force 1 and force 2, given the magnitude of the resulting. So write force 1 as a vector in the direction of the positive x-axis and force 2 as a vector of angle theta. And then with a positive x-axis, write your answer in one decimal. So what does this means that the force 1 is going to be exactly on the positive x-axis. It means it's going to go exactly this way on that's 40 pounds. And then force 2 is something like this, 75 pounds. And this is the theta that you need to find. And then the resulting force, how do you draw the resulting force of a vector is you have to draw a parallelogram. So you got a parallelogram like this. Something like that. And the resulting force is actually joined from this end to the intersection of the other end. So this is what we call as a resulting force, and that is 95 pounds. Okay. So what we're going to do in this case is we can figure out what is this angle theta by using law of cosine. So if you look at this, this is a triangle. It looks something like this. This is 95. This is 40. And then this is 75 because it goes 75 this way. It's also 75 the other way. So we're going to find angle A first. So we can use actually law of cosine to do so. And then once you find angle A, we can find angle theta by taking 180 minus angle A. Because if you take angle A and theta, if you add these two, it's going to be 180 degrees. Okay. So how do you find angle A? Because this is a SSS triangle. And because we know all three sides. So law of cosine can be used. When you do have watch this, when you watch that thing, they use a different format. They use the vector format, but actually you can use law of cosine here. So in order for us to find cosine A, you guys remember how you do use law of cosine? So it's sum square plus sum square minus sum square to something. So which sides give us angle A? Which two numbers? That is the one that you need to add.
B and C, right?
Yep. So that will be 75 and 40. So that means you take 40 square plus 75 square minus 95 square over by 2 times 40 times 75. I think I told you last week that you need to give them parentheses here. And then you have to divide. And then after that, you take the arc cosine of it. And you get A. I think I showed you guys, right, how to do this in last week, right? So parentheses 40 square plus 75 square minus 95 square. And then divided by parentheses 2 times 40 times 75. And then you do the arc cosine of this. So, sorry, my bad. How do I go backwards? There you go. I didn't do the arc cosine. I hate this calculator. Negative 0.3. Gosh. Arc cosine of negative 0.3. Arc cosine. arc cosine. So it's 107.4 something. But again, we are not looking for angle A, we are looking for angle theta. So you have to subtract this from 180. So that will be 72.54. This is the easiest way to find this. I don't know what is the show me watch it way to do it, but this is actually the easiest way to do it. How many decimal? One decimal place, 70.5. Right? Yep, 70.5. So so this is the easiest way to find this. So make sure you guys do the law of cosine in this case, which is easier. The next one that we do also is number 34. You can also use law of cosine and law of sine to do 34, which is very similar to what we just did over here. They give you the U and V, but this time they give you the angle. So it's a SAS triangles. So you have to use SAS is law of cosine also. But I'm going to show to you how to use the vector way to do it. So again, in the test, doesn't matter which way you do, as long as you give it to me correctly, your answer, then I'll take it. Okay. So we have two forces. One is V and U. V is 140 newtons and U is 320 newtons on a hook, and it falls a 45 degrees angle. Find the direction and magnitude of the resulting force of these forces. So if you are taking physics class in your next spring, you're in luck, because this is most vector is used a lot in physics. So like two forces act together in a pulley or something else like that. So you got 140 newtons on V, make sure you know which is V, and 320 on VU, and then you force yourself having a 45 degrees on your on these angles. So what you do need to do here is you have to change all this U and V in what we call as a direction with the direction angle direction form. That means for you take to change this, you have to take your magnitude times with cosine theta plus sine theta. And this is I and this is J. So magnitude times cosine theta times plus sine theta. Or in other words, if you want to put it in a component form, you take the magnitude times the cosine theta. This is the vector I. And then the magnitude times with the sine theta. That's the J. So if you want to do it that way, it's fine too. Then either way is fine. I'm going to use the component form because it's easier. So for U, it's going to be magnitude is 320 times with cosine 0. The reason why it's 0 is because this direction is a 0 degrees because it's exactly on the 0 angles. And then 320 times sine 0. And cosine 0 is actually 1, and sine 0 is actually 0. So this is actually 320 0, because 320 times 1 is 320, 320 times 0 is 0. So this is your component form for the vector U. For vector V, you do the same thing. 140 cosine of 45 degrees. And 140 of sine 45 degrees. Then we need to know what is cosine and sine 45 degrees. Parker, Ryan, do you know what's cosine 45 degrees?
Root 2 over 2.
Yep, root 2 over 2. And sine 45 is also same thing, root 2 over 2. So this 140, you can reduce it by 2, so it's 75. So this this component form for V is 75 square root of 2 and 75 square root of 2. So now you got U and V. So now what you need to do is you add up. So u plus v. So you add these two. So it's 320 plus 75 square root of 2. And then 0 plus 75 square root of 2, you get 75 square root of 2. So this is what we call as the resulting force, but you need to find the magnitude. The magnitude in this case is the square root of this square plus this square. So it's kind of like a distance formula. So you take this fellow, square it, and then you take this fellow, square it, and then you add it, and then you take the, so this is the magnitude of this. This is the first question that they do here. This is the magnitude here. So in this case, now you take a calculator to do all this icky work. So yes, 320 plus 75 times, I hate this calculator. Square root of 2 first, I do this one, times 75 plus 320, and then you square this fellow up. So you get this icky number, m plus. So I just save this as a memory. And 75 square root of 2, 2 square root times 75. And then you have to square this fellow, m plus. So I think the sum came out to be, I hate. So you had to take the square root of something. This is 11250 plus, oh my goodness. I told you I do not like this calculator. MR. Okay. I'm going to use my calculator. This is driving me crazy. Because this is the one that a lot of students get wrong because you cannot round this answer, as I told everyone. Square it plus no. Plus what is that number? 75 square root of 2. 75 square root of 2 square. Just drive me crazy. So that will give me 181,682.251. And then you take the square root of it. That will be 426.24. So this is how we do this question, is 426.24. Let me do 2 decimals, please. And then for the direction, in order for us to find the direction of this, is you do the arctangent of y over x. So this is y, this is x. So like tangent is y over x. So so arctangent of 75 root 2 over by 320 plus 75 root 2. So this is how you figure out your direction for this, is you have to do the arctangent of that. So again, when you do this in your calculator, you need to put parentheses around these two because of the addition here. So 75 square root of 2, close the parentheses, divided by parentheses 320 plus 75 square root of 2. And then after that, you do the arctangent of it. And arctangent of your answer. So this is actually 13.98. Okay. So so this is 13.98 degrees. I think it's 2 decimal places. Yep. So what does that mean if you draw the pictures here is, if you draw a parallelogram to connect this this picture, the resulting force is actually connect from one end to the other end. And this is actually is 426.24 newtons. And then this angle formed from this 320 to this magnitude is around 14 degrees, which is this answer. So in another words, in physics, so let's say that this is something you want to carry, and let's say one people pull this rock 320 newtons directly 0 degrees, and one pull at 140 on the 45 degrees. This rock will move towards this direction. It will move right here, 14 degrees from the 320, and the rock can be moved is around 426 Newton. So this is how heavy the rock you can move. So if your rock is heavier than 426, then you have to increase your one of these numbers. But however, if this rock is 400 Newtons, then yes, then this rock can be moved since you can move up to 426 Newton. So you guys, this is for physics. So if you are doing for physics class, there's a lot of force. One chapter full with force, they're all using vectors. So it will help you to do that. So Ryan Parker, are you okay with that?
Yep.
Okay. Another way I told you before, this is wrong. What happens? What happens?
140 divided by 2 is 70, not 75.
Oh, my bad. Oh, see, should let me know. This is 70. So this is all 70. So one wrong, everything is wrong. Oh, so this is all 70. Thank you for letting me know now. Let me do the direction one first. I can change that to 70 easier. Yep. Thank you for telling me. 10 of this. So this is 13 point. Now this is not 13.9. This is actually is 13.29. This one I need to take some time. Again, is all calculator work here. Oh my goodness. Sorry. So just do that way and then you got the answer. So it's just, yeah. I want to show you another way to do this. So so the another way to do this kind of question is using your triangles, your law of sine, law of cosine. So this is 140 and this is 320. And then this one is 45 degrees. And then again, if you draw this as a parallelogram, so this is the one that you need to find. And then this is the angle you need to find. Okay. So so what we do here is you can find this. So if this is 140, this is also 140. So 45, 45. Let me see how yep, this is going to be using law of cosine. So we can find, let me see, this one. Which one should we find first? We cannot find x. This one you might need a bit more work here. If this is 45, then this should be 135. There you go. You can do it that way. Because the total of these two should be 180. So now we got SAS, side angle side. So we can use law of cosine to find x here. So x in this case is the square root of 320 square plus 140 square minus 2 times 320 times 140 times cosine of 135. This one is actually faster, right? Compared to your vectors. Square root of 320 squared plus 140 squared minus 320 times minus, right, a squared plus b squared minus 2 times 320 times 140 times cosine of 135. So this came up to be 430 point something. And then in order for us to find the angle y, cosine of y is ans squared, which is a 430.53, plus 320 squared minus 140 squared over by 2 times ans, which is the 430 times 0.53 times 320. And put your parentheses here, and then do the arc cosine after that. So this is actually faster than using the vector way to do it. And yes, in the test, you can use this way, it's not wrong. Again, your answer should be correct. Should be the same. 2 times ans times 320. And then you take the arc cosine. So this is 13.29. So 13.29. And this is 430.53. So so up to you which way you want to use in your test. I will strongly suggest you to use law of cosine because that is easier if you know how to draw the triangles and find the angles of such thing. Ryan, Parker, you okay?
Yep.
Okay. Next questions you have for me, D2, for this section 8.3?
Just whatever you think would help on the test.
So like what we just did, right? 8.4 is do the dot product. So dot product is used for the only thing I want to point out the dot product is when you do the dot product is u1 times v1 plus u2 times v2. So it would be u1 v1 plus u2 should be this one is a dot product. So that is first thing doing dot product. Second thing important of dot product is you can actually find the angle if I give you two vectors. So if I give you vector u and vector v, you can find the angle between u and v using this cosine theta is u dot. This is a formula. So what I'm showing you here are the formula for the dot products. Then they have projection u to v. I think the formula is all formula here. I think it's u dot v, v. I think this is a formula. Make sure I think that's a formula for that. So first thing first is how do you find your dot product is you multiply your first component, add it with multiply your second component. So this is very easy. So like 3 times negative 3 is a negative 9. 10 times 5 is 50. So this will give us 41. So a dot product is what we call as a scalar product. That means that it is not vector. Okay, this is something that I want to point out to you is when you do a dot product, your answer is a number, not UV or IJ or vector form. Okay. The rest is pretty much the same. See, like this question 15, I will do that. You want to find the angle given you these two vectors. So the formula is cosine theta. This is a formula. Cosine theta is u dot v over by magnitude of u times the magnitude of v. So this is the formula to find the theta. This is actually the fastest way to find it. So if you do question number 15, so first thing is you need to figure out what is u dot v. So 9 times 8 is 72. 9 times 0 is 0. So in this case, the dot product is 72. And then you figure out what is the magnitude of u. Magnitude is just square, like distance. So 9 squared plus 9 squared. So 9 squared plus 9 squared. So this is 81 plus 81. That will give me 192, I believe. 81 plus 81. 162. So leave it as square root of 1. Don't do anything funny. Don't take out, oh, let's find what is the perfect square that goes in there. Just leave it like that. And then v in this case is square root of just 8. Square root of 64 plus 0, which is so 8. So this one is going to be square root of 162 times 64, because absolute the magnitude of u is 162, the magnitude of v is 64. So so when you do this and then you do the arc cosine after that to find the theta. So 72 divided by the square root of 162 times 64. And then after that, you do the arc cosine of it. So your answer in this case is 45 degrees. So this is 45 degrees. You guys all right here with this? Questions? Anyone have any questions for me?
Nope.
Okay. This one is also the same, like number 20 is also the same thing. I recommend you to, it's a triangle, so I recommend you to draw the triangle out, give me the coordinates, and then you draw this. And then after that, you find what is the length from here to here using your distance formula. And then you find what's the length from here to here to here, and then length from there to there. And then after that, you find what is the angle for each case. And you can use law of cosine here if you, since we know all the 3 sides, or you can use the vector using this formula to figure out the angle. So there are a lot of ways to do this kind of questions. You can use law of cosine, law of sine, or you can use the dot product in this case. Next thing is orthogonal. To prove 2 vectors are orthogonal, the dot product must be equal to 0. This is very easy. So if your dot product is exactly equal to 0, means they are orthogonal. Orthogonal means that these 2 vectors form 90 degrees. So if you have vector u and vector v, orthogonal means like perpendicular. They form 90 degrees. So it's very easy to tell if they are orthogonal. Like this one is orthogonal because when you multiply this is -7. Oh, this is not orthogonal because multiply this is -7, multiply that is 0. So that is not orthogonal. This one multiply, you get -30. This one is 84. So this is also not orthogonal. This one I think is orthogonal. Multiply this, you will get 81 cosine theta. Yep, this one is orthogonal. Because when you multiply this, you will get 81 cosine theta sine theta. And when you multiply the other one, you get a -81 cosine theta sine theta, which gives us 0. So that's why this is orthogonal. You all right here?
Yep.
Questions? And the last one we're going to talk about is this projection. How do we find this projection V to U? Is we have a formula. Where's my formula here? The formula for the projection V to U is U dot V with the absolute value of V squared times V. So this is a projection V U onto V. So this is the formula we have to use for question number 25. Let me show it to you. 25. So if you want to find the projection of U to V, the formula is U dot V, absolute value of V squared, and then after that you multiply this with V. So this is the formula. So first thing, I got U and V here. So you find what is U dot V first. So multiply them up. So 3 times 8 is 24. What is it, 0? 24, and then 4 times -6 is also -24. So this is 0. So this is actually easy. Since this is 0, so this is all 0. So projection U on the V will be 0 in this case. This is too easy. I'm going to change this question. And then after that, U in this case is let me change this question so you won't get 0, because this one gets 0. Which you should, in a test, I don't think so you get. So let's do 3, 4 for U, and let's do V as -8, -6. This one will not gonna give you 0. So this will give me -24, and then that will give me -4. So this is -48. This is U dot V. Next, we're gonna find what is the magnitude of V squared. Now, usually when you find a magnitude, is the square root of your square plus this square. But unfortunately, the good news is because you square it, so when the square and the square root will cancel here. So actually, this magnitude of V is taking this square plus this square. So it will be 64 plus 36, 100. And do not take the square root of it. The reason why is because it has a square in there, and the square and square will cancel up. So so make sure you put 100 in there. So now put into this formula. This is -48 over by 100. And then the vector V is this vector V. So it's -8, -6. So you put all this in here. And then now what you need to do here is you distribute him. So this, when you distribute, you get 48 times 8, 384 over 100. And then 48 times 6, this is 288 over 100. And then you reduce a fraction after that. That one, if I think it becomes, this one becomes 72 over 25. And this one is going to be 96 over 25. So this is where you're going to put this. This is your answer for him. So now, in order for us to find this blank, you have to subtract U from this. We call it W1. This is actually called W1. And this is called W2, the one that you find. So usually U in this case is W1 plus W2. And W1 in this case is the projection U onto V. And then W2 is the subtraction of these two. So what you do is U in this case is 3, 4. And you subtract from W1, which is this 96 over something. Yep, Ryan, thank you for, I didn't see your chat now, I just see it. 96 over 25 and 72 over 25. So what you need to do next is just subtract these two component form and you get your answer. And this answer will be here. Okay, so 3, take away that. These are all, use your calculator, are pretty much easy. -21 over 25. That's fine. And then this one is 4 minus 72 over 25. That will give me 28 over 25. So this is your answer for him. Okay, you guys all right here? Again, this is 0, so it's easy. So if this is 0, then this will be exactly 3, 4. Because it's 0. So yeah. So you guys all right? with this one.
Yep.
All right, so this is 8.3 and 8.4, so this is not too difficult. A lot of formulas. That's the reason why that you need to know the formulas for this case. The next thing I want to talk about is your homework. So before I continue with your next week is going to be a little bit gruesome with homework because you got 4 homeworks left, and all these 4 homework has to be due by next week. So 8.6 and 11.1 is due on Tuesday. And then on Sunday is 11.2 and 11.3. And then on that Monday, the December 14th, is your finals, your take-home finals. So make sure you guys, next week, you got 4 homework, 2 of them due on Tuesday and 2 of them due on Sunday. And then next week is also your last Zoom with me. So next Tuesday, the December 8th, you will have the last Zoom meeting with me. And then we don't have any more Zoom meeting after that. So you have 1 more left with me, which is next Tuesday. So let's talk about 8.6 first, about trigonometric form in complex number. In your notes, it's 8.5. I don't know why your textbook suddenly just changed to 8.6. So the first thing a lot of students make mistake here is how do you draw this, okay? So usually when you want to draw this in a complex plane, your x value is your x-axis is your real, which in this case 4, and your your y-axis is your imaginary plane I, so it's -3. So it's like coordinates. This is 4, -3. So 4, -3. So this is don't tell me it's not working again. So this is the one that I have problems with. 4, -3. Oh, there you go. Oh, that's good. Oh, I thought. So so this is the point. This is how you plot it. So you don't need to draw any arrows. You just plot the point. 4 for the real and -3 for the complex. And then if you want to find its absolute value, you just need to. It's like distance. So you just take the square. Finding the distance. So like square root of 4 square plus 3 square. So this will give us 5. So this will be 5. 16 plus 9, 25 root. You guys all right here with this complex plane? Questions?
Nope.
And if it's just 8i, 8i is just right here. Dot. On the complex plane. That means it's on your y-axis. And 8i, your absolute value is 8 because there is no your real part. So if you have just I form or just a real number form, then your dot is on your plot, your points is on your XY axis. Okay. Now the next thing you need to know here is how to write this in a trigonometric form, Z. So when you have 5 minus 5i, in order for you to write this in a trigonometric form, Z is actually magnitude, which is the one that you just find here, cosine theta plus I sine theta. The magnitude is the same thing you just find over there. For theta, you have to use the arctangent of y over x, the one that we just did last time. This is how you find the theta. But one thing I want to point out to everyone here when you guys do this is watch your quadrant. Because that theta for tangent, positive can be in quadrant 1 and quadrant 3. Negative can be quadrant 2 and quadrant 4. So how do you figure out which quadrant you are? You have to draw you have to dot the point in the complex plane. If your point is on here, then it's quadrant 1. If your point is on here, it's quadrant 4. The point is on here is quadrant 2. Your point is on here is quadrant 3. So for example, is when you guys do 5 minus 5i, which one you think is your answer here for 5 minus 5i? Quadrant 1, quadrant 4, quadrant 2, or quadrant 3? 1, 2, 3, 4. Which one is the right quadrant?
4.
4. So this is a right for him, right? So, and since this is in quadrant 4 tangent is positive or negative?
Negative.
Negative. So make sure you guys know that it's negative in quadrant 4. Okay. So, so how do you write this in a trigonometric form here? First, you had to figure out your magnitude. So you take the square root of 5 squared plus 5 squared. And that will give me square root of 50. 25 plus 25, which is 2 square root of, no, 2, 5 square root of 2. 50 is 5 root 2. So this is how you find your magnitude. Now we need to find your theta. So theta in this case is arctangent of y over x. Y in this case is -5. And x in this case is also -5, positive 5. So arctangent of -1. And you want this usually in a degree form, a radian form. See, they want this in a radian form. So do you guys know what is radian for tangent 1? Arctangent of 1 is tangent what gives us 1? (45°), very good. But in radian, this is pi
over 2. 2 over
pi over 4. 45° is pi over 4. So a lot of students think this is pi over 4. And this is wrong. Why is wrong? This is the one
quadrant.
Yes, because pi over 4 is in quadrant 1. So can someone tell me what is pi over 4 in
Negative
quadrant
pi over 4.
4? Huh? Something over 4. Something pi over 4. Yep, 7 pi over 4. So this will be actually is 7 pi over 4. So your answer in this case is 5 root 2 cosine 7 pi over 4 plus I sine 7 pi over 4. And there's no shortcut to type this. This is how we do it. And a lot of students get this question wrong. It's mainly because of this quadrant problem. This is the one that a lot of people get wrong. And do you know what happens if this is wrong? Everything after that is all going to be wrong. You guys with me here? Questions you have? Parker, Ryan?
Nope.
And if you want to write this in the standard form, it's very easy. You just distribute it back and you will get back the 5 minus 5i. So if you multiply, so if the question asking you to write this back in a standard form, so this is called a complex number. And this is called a standard form. What you do is just distribute 5 root 2 times cosine 7 pi over 4, you get 5. 5 root 2 times sine 7 pi over 4, you get -5 with the I next to it. Okay. So you just do that. You guys all right here with this one? This is not too difficult actually on this section. The next thing I want to point out to you here is how we multiply. Okay, so formulas. So if you know angle vector, the u and v in trigonometric form, the magnitude, and then you got the cosine plus sine, I sine theta. So if you are multiplying these two together, like you want to multiply these two, what you need to do here is you take the magnitude, you multiply it. So you got 2 magnitude. And then the theta, you add it. Okay. And if you want to divide, then you take the magnitude, divide them, but the theta, you subtract it. So this is a formula when you do multiply, divide, and there's no formula for addition, subtraction. So for example, here is for number 18. If you want to multiply these two, so you multiply the magnitude first. So 7/9 times 9. And then the cosine, the theta you add. So this is pi 7 and this is 7 pi. So you add pi over 7 with 7 pi over 9. Plus I sine the same thing. So the good news is this 9 can be canceled. You get 7. You get cosine something. So now you need to add these two fractions together. So 1/7 plus 7/9. So that will give me 58 pi over 3. Plus I sine 58 pi over 3. But if you put this answer over here, you get it wrong. No, 55 over 63. Sorry, my bad. 55. Then this is correct. Sorry, if you put it that, this is correct. The reason why the previous one I say is wrong, if you put 58 pi over 3, you won't get wrong, is because that angle that you have is not between 0 to 2 pi. So you have to keep on subtracting 2 pi until the domain is from 0 to 2 pi. So that means, so you actually, so if you got a number here that is over, it's not inside this given domain here, then you either have to subtract or add 2 pi until it reached this domain. So that's the reason why that if 58 over 3, then it's going to be wrong. But 58 over 63, then it's correct because that is in between 0 to 2 pi. You guys all right here with this? How we multiply them?
Yep.
You want to try number 20? There's no magnitude, even better. So you don't even do this.
So would it just be like cos 4 degrees plus 36 degrees and then plus I sine 4 plus 36?
Again, angles you add. So cosine what? Add this up, you get cosine what?
40.
So cosine 40 plus I sine 40. That's it. You're done. Pretty easy. So this is multiplying. So for dividing, like 21, when you divide, then the magnitude you divide. Your angles you subtract. So for this case, you divide your magnitude. So you get 1/6 cosine. And then you subtract the top from the bottom. 100 subtract 30 is 70 plus I sine 70. You okay there? So it's pretty much simple. Is you subtract this and you divide this. So, and then make sure that that angle is between 0 to 360. So 70 is between 0 to 360. This is correct. So you want to try 22. Parker and Ryan, try 22. So what you get? So it's 2/9. This is easy because we already got 2/9.
And cos 62 degrees. Negative
No.
62.
Yeah, but unfortunately, negative 62 is no good because it's not between 0 to 360. So what you do?
add 180 degrees.
No. Again.
360.
Yes. So what's 62? 360 take away 62.
298.
So it'd be 298 plus I sine 298. This is correct. You got it?
Yep.
So this is not tough. Just, pretty make sure that you're what you need to watch out is first, make sure that you're right quadrant. And second, make sure that the angle that you find here is between 0 to 360 or 0 to 2 pi. That's what you need to watch for. You can use this formula as long as your UV is in the trigonometric form. For example, like question 23 and 24, the UV given to us is not in a trigonometric form. So you have to change it into trigonometric form. Magnitude, you have to take the square root of a squared plus b squared. And then this, for the theta, you have to do the arctangent of y over x, like the one that we just did early on. So you have to do it twice, one for u and one for v. And then one, and again, this one, you have to be careful for the quadrant. Remember the quadrant we just did last time? And usually, and depends on what, since they give you this, means they have to be in radian form. If they put it in this, that means it's in the degree form. So you have to watch carefully what form you do. In my test, I'm not that picky. You can give me in degree form, you can give me to radian form. I'm not picky at all. Okay. This one looks like they all want in radian form. And then after that, you multiply it, like what we did here. And then for 24, you divide, because this is multiplication, this is division. Okay. Now, next thing we're gonna do is power. So this is multiplying and this is dividing. So next thing we're gonna do is power. So the power one is what we call as a De Moivre theorem. Okay. So that means that if you have a plus bi, and then you make it to the power of n. So the first thing you need to do here is you have to change this into the trigonometric form. And the good news about this is your magnitude, if you change it to this, will be power n. And your theta here will be multiplied by n. So if you have a power n, this is a De Moivre theorem, you have to be in a trigonometric form. You change this, your magnitude will be power n, and that will be n times theta. Okay. So the first thing we need to do on question number 26 is you have to change this into the trigonometric form. But if you 26 and 27, you have to change it to the trigonometric form. But 28 and 29 is good because it's already in the trigonometric form, so you do not need to do changing. So let's do see how good you guys changing that. Do you know how to change this into what is the magnitude and what is the theta here? Ryan, Parker, magnitude for this?
The magnitude would be square root of 32. So whatever that simplified is, if there's
4 root 2. Or you can just leave it as 32.
Okay.
I'm not that, because after that you have to power it to the n. Theta, arctangent of what? This is your
4 and 4.
4 over 4, which is 1, right? What form they want? I think they want it in a radian form. So what is that going to be? What's arctangent of 1? We did it just now. 1 is tangent. What is 1? Tangent
Over 4.
pi over 4. And then now you look for your quadrant. Do you know where is 4 plus 4i? This is the one that a lot of students make mistake in my class. And if you get this one wrong, everything you do is wrong. What quadrant is this?
Quadrant 1.
Quadrant 1. And pi over 4 is quadrant
1.
1 also. So this is good. So now what we need to do with 4 plus 4i to the power of 6 is you have to take the magnitude to the power of, to raise it to the power of 6. So the magnitude is square root of 32, right? To the power of 6. You can use your calculator to do this. And then cosine. Then what happened is you have to take your theta multiply by 6. So 6 times, so you get 6 pi over 4 plus I sine 6 pi over 4. Okay. So calculator, square root of 32 to the power of 6. This is 3,276.8. We can reduce 6 over 4, become 3 pi over 2. Okay. If you write this answer in question 26, they will mark you wrong. It's because if you read the question, you say you want in the standard form. Standard form means this, a plus bi. So if a question is asking for us in a standard form, means it's a plus bi. This is called trigonometric form. So what you need to change in standard form is just multiply this inside. So take out your calculator and type 32768 times with cosine of 3 pi over, so cosine of, this is 3 pi, hit this calculator again, 3 pi over 2, nope, it's not working, 3 pi over 2, and cosine of it. This is 0. So this will give us 0. And then now we do the sine pi, 3 pi over 2. I think that's negative 1. And you take the cosine of it. Yep, this is negative 1. So that means your answer in this case is negative 32768i. Don't forget this one has an I on it. So this is negative 32768i. You guys all right here? Questions? Okay, so make sure you guys read the question carefully, what kind of result they want you to put in. Some result wants in standard form, like what we have here, and some result wants it to be a trigonometric form, like magnitude and cosine. So be careful with that. And the last thing we're going to talk about is doing what we call as a cubing. What is a cube root of this this function here, this trigonometric form? So the first thing is there are formulas, and this is a formula for it. This is a formula for the to find the roots. So if you have a cube root, you have to do it 3 times, where k in this case is 0, 1, and 2. So you plug k 0, 1, 2. If you have a 4th root, then you got 4 answers. 0, 1, 2, and 3 means your k is 0, 1, 2, and 3. So this 0, 1, 2, and 3 depends on your k, on how many roots, how many cube roots or 4th root or whatever root you have. So how do we do this kind of question? Number 21 is, so the r is the magnitude, the theta is the angle. So in this case, and the n is how many roots. So in this case, if you look at this, your r is 216. Your theta in this case is 5 pi over 6. And your n in this case is 3 because it's a cube root. Okay, so if you plug into this zk formula, it's going to be cube root of 216 cosine of theta, which is 5 pi over 6 plus 2 pi k over by 3. It's a big formula. I sine duplicate 5 pi over 6 plus 2 pi k over 3. And now we know cube root of 216. This is actually 6. Because 6 times 6 times 6 is 216. So now you have to substitute when k is 0. So you will get your answer as z0. 6 cosine of 5 pi. This will become 0 because k is 0. Over 6 over 3. So when you have over 6 and over 3, you can multiply this to become 18. So this is for your first answer, Z0. Next, we have to do for Z1. Z1 means K is 1, so you get Z1. 6. Now, in order for us to do this, you have to put this to become 1. So you have to add 5 over 6 plus 2 and then divide it by 3. So 5 over 6 plus 2, you will get this, and then you have to divide this by 3. So it's 0.9444, but you need it in fraction. I think this one is something over 18. What is, yeah, it's something over 18. I think it's 17 over 18. Let me see. 17 over 18. Yep, 17 over 18. So this is actually 17 pi over 18. Now, I will show you, and then after that, you do the same thing for the last one. K is 2. So Z2 is 6 cosine, and then you plot this to become 2, and then use your calculator. That will become 29 pi over 18, I believe. And I'll show you the shortcut. So the long way is you use your calculator and try to figure out what happens when k here is 0, 1, and 2 for this question. And then this icky stuff, use your calculator in terms of pi. This one is easy. This one you do not need calculator. So in order for us to use the other one is without any using calculator is this. What you do is you look at this 2 and you look at this 6, you multiply it. This is 12. So 6 and 2 is 12. So in this case, you just add 12 pi to the top. So 5 plus 12 is 17. And then you add another 12 pi. 17 plus 12 is 29 pi. So so that is another shortcut to one way is you do the whole thing using K012, which is a lot of work. I mean, a lot of work, you can use your calculator to do it. Another way is this, first you have to figure out this by yourself, which is very easy to figure out because for K is 0, it's very easy. And then the second thing, what number should we add on here? It depends on the 2 and the 6. So whatever you have down here, you multiply it by 2, and that is what you need to add to every term for this case. And then lastly, you have to graph this. So question B is asking you to graph this. Graphing this is 5 pi over 18 is in quadrant 1. 17 pi over 18 is in quadrant 2. And then this one is quadrant, so 1, 2, and I think it's, what's 29 pi over 18? 29 over 18. This is 1.6. This is in quadrant 4. So this is in quadrant 1, then 2, and this is in quadrant 4. So your answer in this case will be this one. Give you 1, 2, and 4. This one is 1, 3, and 4. 1, 2, and 3. This is the one that give you 1, 2, and 4. So make sure you know which part is it, and how do you determine it is because 5 pi over 18 is quadrant 1, 7 pi over 18 is quadrant 2, and 29 pi over 18 is quadrant 4. And then the last question they want you to do here is just change the standard form. Means you multiply the 6 over here, and you got a lot of decimals. That's why the answer wants you to put in 4 decimal place. So you take 6 times cosine 5 pi over 18, you get a number. And then you take 6 times sine pi 5 pi over 18, you get a number, and then put an I on it. And that is for Z0. And you do the same thing for each one of these. So this is how we do this kind of problems. In the test, I won't ask you question B, I won't ask you question C. So I will just ask you this part, question A. Okay. So in your finals, you only get the A part here. Okay. So you just need to find what Z0, Z1, and Z2 for cube root. For square root, you only find 2. For cube root, you need to find 3. For fourth root, you need to find all 4. So the more roots you have, the more you have to do. Like this one is a cube root because it's x cubed. So if you get something that is not written down like cube root or fourth root, this one is going to be cube root because it's x cubed. This one is a fourth root because it's a fourth power. So mostly my type of question in the finals will look something like that, like fourth root of something or cube root of something. So it's very straightforward type. So this is 8.6. So don't forget, when you come back on next week, we will do 11, the whole chapter 11, 11.1, 11, 2, 11.3. So because that will cover everything in your homework here. So 11 is easier than what you did so far. So that's it for today. I'm going to stop sharing and stop recording.